On November 10th, 2022, Charles, a 49-year-old hotel maintenance worker, walked into the third floor boiler room. He was found the next day by the fire department, slouched in a corner, overcome by carbon monoxide. Charles wasn't new on the job. He'd been doing it for 7 years. Stories like this happen far too often. We've all heard that carbon monoxide is dangerous. It's called the silent killer because it's odorless, colorless, and tasteless. But have you ever wondered why it's so dangerous? Today, we're going to look inside the human body and see exactly what carbon monoxide does, why it can kill, and why even low-level exposure can cause serious problems. I'm Ray Wolfarth, and this is the Boiler Room Detective Channel. My 14 boiler books are available at T.F. Campbell, Pronto Heating Supplies, Amazon, and heatinghelp.com. Think of your red blood cells as delivery trucks. They pick up oxygen in your lungs and deliver it throughout your body. The oxygen rides on a protein called hemoglobin. As long as oxygen is being delivered, your brain, heart, muscles, and organs work normally. But then carbon monoxide enters the picture. Here's the scary part. Your body actually prefers carbon monoxide to oxygen by a factor of 200 to 250 times. So when CO is present, these delivery trucks ditch the oxygen and grab the carbon monoxide instead. No molecules bind tightly to hemoglobin, forming carboxyhemoglobin. This starves your tissues of oxygen. The brain and heart suffer first because they have the highest oxygen demand. It gets worse. It makes it harder for whatever oxygen is left to unload where it's needed, disrupting energy production. In other words, your red blood cells basically go on strike. Your body is suffocating from the inside out, even though you might still be breathing normal air. Carbon monoxide doesn't leave your body quickly. It's like a squatter. In fresh air, carbon monoxide has a half-life of about 5 hours. Let's say you've been exposed and the carbon monoxide level in your blood reaches 100 parts per million. After 5 hours in fresh air, the level drops down to around 50, or half the amount. 5 hours later, it drops down to about 25, about half of the amount. This is one reason severe carbon monoxide poisoning victims are sometimes placed in a hyperbaric chamber. The increased oxygen pressure helps force the carbon monoxide off the hemoglobin faster. The brain and heart are oxygen hogs. They require a constant supply of oxygen every second of every day. When carbon monoxide starts stealing oxygen, these organs feel it first. That's why some of the earliest symptoms include headaches, fatigue, dizziness, confusion, nausea, and difficulty concentrating. The problem is that these symptoms look like a dozen other things, like the flu, a cold, food poisoning, exhaustion, or dehydration. As a result, many people never realize carbon monoxide is the real problem. So what causes carbon monoxide? It's produced anytime you have incomplete combustion, common in furnaces, boilers, water heaters, engines, even stoves. In the case of Charles earlier, the flue pipe was blocked with sheet metal, causing the flue gases to spill into the boiler room. Some of the causes in some boiler rooms are poor burner adjustment, inadequate combustion air, blocked flue passages, backdrafting appliances, or negative building pressure. In fact, a negative pressure of 0.03 negative inches water column can be enough to pull flue gases back from the flue. Most people think carbon monoxide is only dangerous when the levels get extremely high. That's not true. The carbon monoxide levels might not be high enough to trigger an emergency response, but occupants may begin to experience frequent headaches, fatigue, memory problems, difficult concentrating, irritability, poor sleep quality. I've seen situations where occupants said, "I don't feel right in this building." Then they leave the building and suddenly feel better. That's a huge clue that carbon monoxide may be involved. As technicians, we can do several things to protect ourselves and our customers. Always carry a personal carbon monoxide detector. Test combustion equipment annually. You can use your combustion analyzer to see if there's any carbon monoxide in the room. Perform a combustion analysis and calibrate it outside. Check venting systems. Verify combustion air openings are sized enough. Investigate occupant complaints of headache or fatigue. Building owners should install carbon monoxide alarms near sleeping areas and maintain them according to manufacturer's instructions. I like seeing carbon monoxide detectors inside boiler rooms. Carbon monoxide is dangerous because it steals oxygen from your body. It doesn't matter whether it comes from a boiler, furnace, water heater, generator, or vehicle. The result is the same. Your blood loses its ability to deliver oxygen when it's needed most. And while high levels can kill quickly, low-level exposure can affect people long before an alarm sounds. If you're a technician, test every appliance. If you're a building owner, install and maintain carbon monoxide detectors. Because when it comes to carbon monoxide, what you can't see can absolutely hurt you. I'm Ray Wolfarth, Boiler Room Detective. Stay safe, and we'll see you on the next case.